All right, 3:10. All right, well, thank you everybody for joining and for giving us this opportunity to talk about the National Bathymetric Source. Glenn and I work for NOAA Office of Coast Survey. I'm Katrina and Wyllie, that's Glen Rice. And so we'll give you a quick overview of the project and then I'll hand it over to Glenn.
And we'll also just say, really nice to be back. Really nice to see all you guys in person.
Haven't been in an auditorium in like 2.5 years, so this is great. All right, so the National Bathymetric Source in Coast Survey. So this is a project we create and maintain high resolution bathymetry for the nation, and it's composed of the best available bathymetry. So our primary mission in Coast Survey is navigation.
You can't see the slides.
You can't see the slides?
I just got a text from Kevin.
There we go. So we're using, so we're building the best available bathymetry, and our mission is navigation. So we're supporting the transition to automated cartography. You can see on the images, the chart suite is being modernized on the right there in the Marine Chart Division. We're also supporting precision marine navigation. So that's providing mariners with enough information to do near real-time navigation. And so what we've built so far is New York to Maine and Texas to Mobile, Alabama. We are currently building in the Southeast, and our build plan takes us to the rest of the East Coast, the Great Lakes, the West Coast, Alaska, and the islands. And so as we build a region, we are also maintaining it. So as new sources become available, we're including them.
Is it all right to ask questions?
Please, yeah.
Yeah, so I'm curious about how that order was determined. Clearly, you've done the most important part first.
Yeah, New England's the best. So these regions are based off the Marine Chart Division production branches. So these are broken up for Marine Chart Division. So we picked a group like that to build the bathymetry to support their re-scheming of the ENCs. And we started in New England, besides being the best.
Because that was where the Recharting Division was
That's where
normally
they're
starting their re-scheme process.
Okay.
So the project targeting re-scheming, we started there. And I think
So it wasn't an AIS study that said, here's where we have the most traffic or most accidents or anything.
it was just kind of, in fact, the project initially started in Seattle area because it was, that was where re-scheming was going to start. And then when that was, the focus changed in terms of then going to the Gulf of Mexico. That was mostly because at the time we had some supplemental hurricane funding. And so we had contractors that were under that funding. And so it made sense to take that.
Perfect. All right, so when we're collecting all these different sources, there's all sorts of different sources of bathymetry. Primary sources are NOAA and Army Corps hydrography and topobathy LIDAR, as well as our external source data, such as like USGS, other agencies and academics. But regardless of the source, we have to know some minimum metadata. We have to understand how deep it is. So that's your datum and your units. We have to understand some quality metrics, things like coverage, uncertainty, and feature detection. And then also you have to understand the origin. Where did the survey come from? What's the source information and the license on how you can use it? So looking at quality, how well do we know it? These are coming from the International Hydrographic Organization's quality bathymetry attributes that are already defined. So this is your vertical and horizontal uncertainty, your start and end date, coverage, and features. So we're using those metrics because they're already defined and that helps us with automation. And so for coverage, it's a little bit of a challenge because we have different types of coverage. We have, if you look on the left, a channel that is full coverage from bathymetry, and then you have some coverage in the south that is a combination of side scan sonar and concurrent bathymetry. And in the north there, you have some just set line spacing bathymetry without side scan sonar. So what we're doing for the area of concurrent side scan sonar and bathymetry is we're doing an interpolation. So all those nodes that are marked interpolated, we're increasing the vertical uncertainty and we're marking them as interpolated. That way we don't pick soundings from them. And then on the right, you see a generalization. So this is where when we still have gaps without any kind of supporting information, we interpolate again. And those nodes as well are marked as interpolated, and they also have a higher uncertainty assigned to them. All right, we'll keep going this way. There we go. And so one of the reasons that we're doing generalization is because a lot of our coast is not surveyed to complete coverage. So having this generalization product allows for things like depth contours and depth areas to be created, as well as modelers to understand the seafloor, just in general, like the trends of the seafloor. Okay, so this is an image off Cohasset, Massachusetts, of the National Bathymetry, and it's made up of many different sources. So all of the colors represent a different contributing source to the bathymetry. And so what we do is we also have a raster attribute table that is associated with that contributor layer. So it's a geotiff with elevation, uncertainty, and contributor. And then this raster attribute table, for every color that you see here, it lists that source and all of those quality metrics that were collected. It propagates that through to this table. So you can look up, the source institution, the survey ID, the license for use, the features detected, and coverage. All right, so here are the buckets. When we deal with sources, we put them into the different buckets. So we have qualified, like I said, going through the hydrographic survey division for qualification, assessment. We have unqualified. This is to get data to our the mariners and the public quicker, with a quicker throughput once it's available to us. So it kind of jumps the queue so we can get it out there. It does not go to navigation products until it's been qualified. And then sensitive, so this is internal only. It's something that we cannot share with the public. So that means that we have different pipelines for different users. So when we build the bathymetry, we have different pipelines. We have our navigation pipeline, our internal pipeline, and our public pipeline. So I'll go through those briefly. The navigation products that we're making are to the chart datum. So mean low water is a typical one that you'll see. All the sources are qualified, so no unqualified and no sensitive. We create these elevation attributed soundings and quality metrics, that's your CATSOC, category zone of confidence, for a marine chart division that supports the re-scheming of the ENCs that they're doing right now. And then we're also creating S102 products for the Precision Marine Navigation Program. And so what you see here is the Port of LA Long Beach, and providing this bathymetry to the mariners directly lets them pull out soundings and contours on the fly. So if they wanted to find their safety contour or whatever they want to see from the data directly, the PPU unit allows them to do that. And so not only are we building these high resolution bathymetry surfaces for Port of LA Long Beach, but we're also putting them up where we have the national bathymetry built out. So this is showing Boston, and here are the different regions that we've posted for the New England region. And here's Houston Galveston, one of the biggest, or if not the biggest, ports in the country. This is again the high resolution bathymetry with all the sources together, curated. And I think it's important to say that while those types of users, like our pilots for commerce and for safety, are very important for our mission, it's also worth understanding the bathymetry for the everyday mariner. So looking at some raster charts and seeing the bathymetry behind it, I think you give them an extra view into what's really going on. Something like this, where you have just some sparse soundings and you look at the bathymetry, it might provide an understanding of where to anchor or where to go diving or where to go fishing, depending on what that the user is interested in. All right, so besides navigation, we have our internal project planners. So that is our Hydrographic Surveys Division operations branch. So we're providing these 3-layer geotiffs, elevation, uncertainty, contributor, with that raster attribute table. And this includes all the sources. So it's unqualified, qualified, and sensitive, because they're using this data to assess where to survey next, or where to go and get new external source data that already exists and process it through. So providing this bathymetry helps to update the initial survey layer, like how good is the data that we have on the coast. And having the sensitive data and unqualified data included allows them to just be aware of everything that's out there. So even though the sensitive might not go to or will not go to navigation, at least they know about it in case they have to send an asset themselves if there's a pretty significant danger to navigation in an area. Okay, and finally, our public blue topo product. This is not for navigation. we're very excited about this because as we're building this bathymetry, we're realizing that besides navigation, this is foundational to all sorts of ocean science and other users. And so we created this product called Blue Topo, and it's not to chart datum, so it's not to mean low water, any of the local datums. It's to NAVD 88, so North American Vertical Datum of 88. We provide the qualified and unqualified sources. And again, it's the same 3-layer geotiff with the raster attribute table. A recent example of how people can use this Blue Topo, NOAA's Office of Coastal Management was working with New England states, Maine, New Hampshire, and Massachusetts, and they were taking this Blue Topo product and creating geoforms from it. So this is the main seascape project. And so this is segmenting the seafloor into different geoforms. But there are many other uses for Blue Topo. It's, again, foundational. It supports NOAA's efforts for the new blue economy, as well as coastal resilience. As you can imagine, marine biologists and ecologists and infrastructure and energy siting and modeling and coastal resilience in terms of flooding and seafloor change. Like, you need the bathymetry to do all of this work. It's a primary input to a lot of science. So Blue Topo, we're excited to say that we set up a website on the NOAA Coast Survey page that you can go to find out more. And it links to the AWS bucket where the data is located. So right now we have our New England and Western Gulf of Mexico data in there. Soon we'll have our Southeast, so we should have that up there by the end of this fiscal year. There's also a frequently asked questions link and some specifications if you want to look more about what the attributes are and what they mean. So I've talked a lot about why and what we're doing, and I'm going to hand it over to Glenn to talk about how. I don't know if that works.
Thanks. Yeah, so I'm going to start basically here, because that's really where a lot of this came from, was with Shep's thesis on bathymetric database, and then of course Rick trying to carry it forward in Rick's indefatigable way through, hell or high water. But a lot of what Shep talked about in his thesis was very cursory. It was kind of like, let's build a database of bathymetry, which is an important first step. But I think what we found when we were actually trying to do it was that there was a lot more to make it operational that was important. And so we've kind of struggled with those over the last couple of years of trying to make this project into an operational program, really. And so, all the way there on your left, you have kind of our scraper process that goes out and finds, pulls down data. Not only new data, but data that's changed. So trying to make sure that, Galveston District, which has just taken down a whole bunch of their surveys, and they're going to put them all back up, some of them with the same names, but different data, we know that, and we can find it, and we can pull it down and make sure it gets into our process. So certainly having the data is the first step to building a robust process. The second step is really to take all the data, make sure you have the quality metrics to support your combined engine, make sure you can get it onto a common datum so when you mash it together, it's something meaningful, and really provide a space for somebody to look at the data before it goes into the combined engine. People do add value at this step. Then the next phase is really to combine all that, mash it together, and then kind of like create that national bathymetry. And as Katrina was highlighting, there's really 3 different versions there, depending upon how the combine happens with that qualified source, the unqualified source, and then sensitive. And then we actually have a 4th one that we've added now, which includes kind of pre-compiled. So we're pulling in the chart, we're pulling in like GMRT, for instance, to help supplement data that we haven't been able to ingest ourselves yet. So after that, though, like to get something meaningful, you can't just put it into a database. You got to get it back out and make it into the products that is useful for something. And that's like a whole other undertaking in and of itself. And so to do that, there's the various processes that Katrina was just talking about to make the different products at the, resolutions or the format or the, various products or including the right data that needs to come out. And somebody sitting there manually managing all of that is an overwhelming process when you're talking about a program that works on a national scale. So really trying to make as much of this where people are adding value where they need to and keeping them out of the way otherwise is really important. And so we spent a lot of time trying to build an engine that does that. But like, so to take it back from like the machine, it's like, why did you build the machine that way? This statement is a kind of a cornerstone of the whole thing. So when I inherited this project, it just so happens that there was a previous paper written in 2017 for the hydrographic, US Hydrographic Conference that really was based on kind of this context. And it's really different from how a lot of other HOs or really anybody has come at this process, which is most people just say, newest data is better, put it on top. But I think, interestingly enough, when you kind of start thinking about it, it's like, well, is that always true? And so if you have two surveys that are over an area of high change, so here we have Hatteras Inlet, which changes drastically in the middle, and then over on the sides, not so much. So if you have these two surveys that overlap the same region, like what do you do? Because probably the older data, but might be higher quality, is really the data you want in some locations, and in other places, you know, you actually probably really should just take the newest data regardless how poor it is, because the area changes so much that probably still is a better representation of whatever's there. So mixing those two, I think, is kind of the cornerstone of kind of that concept. So, you know, in those areas of high change, you know, you're probably taking the green survey, newer, lower quality. And then out here in places that are more static, you're probably looking at using the older, higher quality data. But you'll also notice that there's kind of an embedded assumption here of selecting one survey over another. We're not averaging surveys, which is also how people come at this process. And we've, I think, naturally done that because we tend to work in shallow water, which generically is a place of higher rates of change. And so this is, and probably there's more data. And so that's maybe a more appropriate way to come at the problem in shallow water. If you move into the deep water, certainly there's other ways of coming at it. So the reason that I think that this was so apparent to some people who kind of kicked off this whole idea of like, hey, the newest data isn't always the best data, is that traditionally the cartographic process within Office of Coast Survey really started in the Hydrographic Surveys Division, where they used to make H-cells. And so the people who took the data and then tried to turn it into a cartographic product looked at the data that they were getting in the context of other data that was available. And some places they selected this, and some places they selected that. And it was a very like manual process. And basically, I think what we're trying to do is codify that as a business logic. Like that's really the cornerstone of what we're trying to do. And as a scientific agency, it's important that we're repeatable, we're transparent, and we're open. So those is kind of cornerstones for like how we've built what we've built. To be open for us, it was really important to try to build on engines that we could then share what we were doing. It wasn't trapped in some logic that we couldn't share with anyone really. So we've chosen to kind of go this route in terms of how we've built the National Bathymetric Source Engine. And then there's another bunch of other kind of like underlying axioms that kind of then fall out of that. So we try to build a process that's data-driven. So we don't have people making kind of qualitative selection of what's going on. But then also, instead of like fixing the product, which is really interesting because as we've gone back to try to pull old data, like there's a lot of like fixing the product that happened. When you actually look at the data, there's a whole other mess of stuff going on. And it's just, you cannot create an open, transparent, repeatable process when you're constantly just fixing the product. And so we have worked really hard and we spent a lot of time rebuilding things because we're either fixing the data or fixing the process. We're not just kind of polishing what comes out. So those are really kind of cornerstones of how we've chosen to work. But then the other really important thing for us is that throughput matters. When we're trying to build on a national scale, if we're going to build out the whole country in a reasonable amount of time, like we have to get data through the process. But it also means when new data comes in, we can get it back out for whoever needs to use it as soon as possible, like shooting for same day turnaround kind of thing, not the kind of multi-year process that currently happens with a lot of the data that Coast Survey passes through. So I think what I want to do now is just kind of focus in on specific parts of the process and the kinds of things that are still under heavy development, because I think that that's really what why Larry had requested the talk was like, what are you guys doing? What are the kinds of things that CCOM might be interested in? So 3 things come to mind, specifically in the scraping process. So on the left there, you have the fisheries sonars, so there was about 2 years ago, I think we did a paper with some interns to take all the EK60 data from the Bigelow specifically and process that through. But that whole thing just kind of has gotten so far. And what we'd really like to do is be able to start pulling that data directly into the NBS, which gets a little bit to your question about that full resolution. Like now we're dealing with water column data and turning it into points and like doing the whole hydrographic process to it. But similarly, we've already undergone a similar effort to use cluster, which was developed in HSTB by Eric Youngkin, to pull down the multi-beam side of NCI and put it through cluster to then also put that into our process. Because a lot of that data hasn't even really made it directly in. We're using GMRT to supplement because our external source data team just hasn't had the time to crunch through the massive amount of data that really the GMRT team already has. And then, satellite derived bathymetry. So that's another one that's kind of up and coming is as RSD really rounds out their tool, trying to make sure that we can take satellite derived bathymetry and get it through our pipe to update the places where it's appropriate in as fast and streamlined way as possible. Moving on through our pipeline here. So the next step is really this preparation step. And this is really the first place that we attacked in terms of trying to build an automated machine that handles the whole process. And really starts with this interpolation thing, which is really kind of awkward. Having been a hydrographer and worked on a ship, the idea of interpolating was just like very offensive to me at the beginning. But I have to say, given the wide variety of data that I've now been exposed to, certainly sometimes that's really better than what's there. And if you think about it, a lot of the contours, depth curves that are generated in these regions that are on the charts are essentially interpolation already. So it's really not any different than what we've historically done. So in that sense, on the right there, you have kind of your interpolation, which is more or less what we're doing. We're just tinning. We're just doing linear interpolation. Because when you're making up data, you're making up data. So if you're looking at your stool of hydrography, your Greenaway stool of hydrography here, like that's how deep is it? What's important are the quality metrics that you assign to it. And so that, I think for us, how well do you know it is really the right place to have that conversation. So I certainly talked with Elias and Kim about this a little bit. But this morning I decided to take another little bit of a hack at basically sampling 2 lines where we have full coverage, doing a Fourier transform along one of those lines, and then essentially summing up the power spectral density, starting at your lowest frequency, and then as you move away, like what your uncertainty would be as you spread those lines apart. So that's the blue line that's there on the right. And then what I did was I took the interpolation that we standardly do and differenced it with the actual bathymetry. And essentially the maximum uncertainty that we were experiencing, looking at, I think it's at the 95 percentile of all that bathymetry along the line, are the orange spots. And so this is an area right out here off the coast, which you can see is fairly dynamic. And it actually predicts what the uncertainty should be fairly well. So this is kind of this assumption that the seafloor along track is the same as the seafloor across track. Probably could run lines in both directions and maybe take care of some anisotropic effects. But I think that this is a good way for us to move forward, not only with assigning uncertainty within the NBS, but then also in terms of how we plan surveys in the future. So our operations branch within the Hydrographic Surveys Division, I think sometimes struggles with figuring out what the right line spacing is for sending out a contractor to survey an area. How far apart should the lines be? Well, maybe you go out and you do some really sparse lines and you put them closer together, to essentially try to satisfy the criteria for how good you want the survey to be. Because it really comes down to meeting those quality metrics, like what is the vertical uncertainty of the interpolated bathymetry? How well do you know it in between where you've actually taken measurements? So just in the interest of, for this talk this morning, also found another area that was a little bit flatter, maybe not quite so dynamic, and ran the same thing. And you can see that the Fourier transform there on the right actually underpredicts. But if you look at the vertical scale, we're down in the centimeter range. And so in that case, well, this is all going to be uncertainty that's essentially on top of your measurement uncertainty anyway. So in that sense, in this depth of water, your vertical uncertainty is going to be 0.5 meter or something anyway. So in that case, you're kind of determining like, am I A1 or am I A2? And so I think this would be a really, really interesting thing for somebody to do as a master's project, or may even lead to a PhD. I'd love for somebody to pick this up and run with it, please. Let's see. So the next thing that's really in that whole review step is datum transformations. And this is a sticky wicket because NGS, of course, is where datum transformations properly belong, in NOAA, in the federal government. But operationally, Office of Coast Survey really needs to be able to handle this, not only for how we handle our own data internally, but then in the context of the NBS, we have to, all this Army Corps data that comes in is in state plane and whatever datum that happens to be in. And we really need to be able to mash it together. And so everything has to be in a common datum. So we have to have an easy way to do datum transformations. But the first step is communication of what those datums are. And so for just as a quick primer for those who are not familiar, a lot of our datums within the US are kind of live within VDatum. If you're going to go in and do a datum transformation, use VDatum. What VDatum is essentially doing is it's taking essentially a reference ellipsoid of some sort, adding a geoid, adding a TSS, and then putting on your water level separation. Well, I should say subtracting the TSS. For some reason, that has an inverted direction. I think you can talk to Kurt Hess about that, although he's retired at this point, I believe. So good luck. So if you want to properly describe mean lower low water, and any of these are changing, you essentially have a different definition of mean lower low water, which is really problematic when you're trying to mash these things together and have some sense of what the uncertainty is. When you're doing your datum transformations, if this is constantly like an evolving definition, it essentially becomes an ensemble. You have a whole bunch of definitions which are all really the same thing. And so it gets kind of goofy as you're transforming in and out and back and around, just kind of have this ever increasing uncertainty. So essentially what we would like to do, I think, is be able to specify these clearly as part of what the datum is. When I say mean lower low water, I mean, this geoid with this ellipsoid with this TSS from this version of VDatum and this, and so carrying that around as part of our process, I think, is something that we're trying to institute. And then essentially as it comes in, that means we could then, it comes in as an ensemble. You have to add essentially the fluff. But then as we do datum transformations internally, we're not continuing to increase the uncertainty that's associated with our process, because it's really just the uncertainty associated with the definition of the datum. So actually uncertainties could go down if you're going up to the ellipsoid. So just kind of some interesting concepts.
What does TSS stand for?
Sea surface separation.
Topographic seas.
I don't know. I always see.
Okay,
TSS.
thanks.
Yep. You need to ask Kurt. Let me know what he says.
Topology of the sea surface. Someone put in the chat.
There we go. Thank you. Is that Barry?
Barry, yeah.
Thanks, Barry.
Thanks, Barry.
Thanks, Barry.
Okay, so, and I also just wanted to part of the reason that I also said version of VDatum, but then the specific region. So these definitions actually change by VDatum region as well. So each one of these regions might have a different geoid applied, clearly has a different sea surface separation model, although some of them bleed from one to the other. So being able to do that clearly and consistently and then have the bookkeeping to keep track of which ones were used, I think is just generically something we would like to have as part of our process. But then the other thing that we think is really important, not just for the NBS, but really to facilitate precision marine navigation, is the concept of a chart datum. So this isn't maybe a datum in the sense that like NGS is going to define it. It's really an abstraction layer where chart datum is represented both by chart datum B and then also, datum B and datum A. It's just that they have different topology in terms of where they actually are expressed. So if you're on either side of a dam, like there is a chart datum, But it is one thing, so you could essentially put on a chart, this is in chart datum. Or on the bathymetry, say this is chart datum. And then when you provide the water level heights from a tide gauge at the bottom and a tide gauge at the top, they're both just in chart datum. So you add them together, makes it really easy for a vendor to then make sure that you're like applying that real-time water level height. So it's really just an abstraction layer, but I think it could be really important in terms of kind of simplifying how we currently work. So hydro health. So Katrina mentioned hydro health earlier, but it's really the kind of other component. So I said earlier, like quality metrics matter, but then also time is how most people do their supersession process. So this is really the time component, is saying this area changes really fast. So these areas that are light green, like south side of Long Island Sound, but then there are areas that don't change very much, like these areas that are in deep water. And so making sure that you're essentially applying a rate of decay. So this is what helps you take care of the case of Hatteras Inlet, like we were talking about earlier, where if you have an area that's at a high rate of decay, then the quality goes down faster. But if you have an area that's relatively static, then a new survey that comes in that's at lower quality will not supersede a higher quality older survey. This really gets at some of the work that like Cassie Bongiovanni was doing when she was here as well. She was doing it, I think, strictly more in like a riverine environment, but this is really an effort that Coast Survey needs to carry forward to essentially round out not only how the NBS works, but then really integrate it into the rest of how Coast Survey thinks about the quality of the bathymetry we have. Because making sure we have this common concept of the quality of the bathymetry, I think will avoid some confusion in the process. So, anything else you want to say? So just to think about kind of the tail end of our process, the products that we're producing. Automated cartography. So this is clearly something that was, I guess, the Marine Charting Division in collaboration with some folks here. We're at Canadian Hydrographic Conference and kind of won the student award, I think, for kind of trying to automate a cartographic product. And that included Noel Dyer, who I think is kind of carrying the torch on automating cartography within Coast Survey. But this is really interesting to the NBS because I think really gets at the vision of what the NBS is supposed to do, which is kind of provide that what used to be the H cell to the Marine Charting Division, because currently that cartographic product that used to exist in the Hydrographic Surveys Division was moved to the Marine Charting Division, and I think has caused some difficulty in the workflow that they have, since it was really tooled to deal with that H cell. And so if we can get to something like this, that's an automated cartographic product that eases the burden there, then we're just kind of streamlining the whole Coast Survey process. So this really gets more at like the Viz lab, because I think something that we really struggle with is how to get people to appreciate that vertical uncertainty. I talked a lot about, boy, it would be nice to like have a way to better estimate the uncertainty that's associated with where we've interpolated data. But if nobody ever looks at it or uses it, it's kind of pointless. But it's the same thing with an MQual, right? Really, that raster, this contributor layer carries forward not only who collected the data and when they collected it and license for use, but then all those quality metrics. And being able to use that information in a way that is more natural for people who tend to only look at the bathymetry, like how deep is it? We really need to educate people on the value. And so in terms of those raster attribute tables as well, so this is thank you to Brian and Brian, who have been working to help update the bag to include a contributor-like layer in the bag. And so this will help ease the Coast Survey process, where right now, all this information is kind of going into a weird holding place. But if we can get all this information back into the bags that are on NCI, everybody should have access to the same information that we're using to drive our process. And we feel like in terms of being open and transparent and making a repeatable process, making sure that everybody has access to the same data that we have is really important. But interestingly, there's also a similar proposal moving forward, primarily I think with Germany, to include that same metadata layer or a similar metadata layer in S102. So S102 is the new precision marine navigation format. I think 2.1 has just come out, and this would be like a 2.2 potential version. And that really would then help facilitate better automated cartography. Katrina showed kind of soundings and contours that came from some bathymetry that's out there, but they can't tell which data is interpolated. Therefore, they might be pulling soundings, which is not exactly appropriate, from data where they shouldn't be. So this would, carrying forward this information for, hey, this data is interpolated, this data is not, would help you drive that process. So fluff mud is an interesting thing. I swear Katrina likes to bring it up because it stresses me out. Because it's really nice when you have one watch, but then once people start having 2 and 3 watches, it's like, what time is it? Well, how deep is it here? We work a lot with acoustic depths. We think of acoustic depths as the true depth, but this fluff mud thing, boy, we run into it more and more as we try to incorporate different surveys. These areas where there really isn't a bottom and there are people navigating in that fluff. So if you go through with a high frequency sonar, you get one depth. You go through with a low frequency sonar, you get a different depth. And boy, does it make weird looking products when you try to figure out how those go together. But ultimately, it's also bad for under keel clearance. If you're reporting that, well, we're only going to use high frequency sonar and get the top of the mud, people will complain because they are losing navigable depth in their mind. So then what is a feature in the mud? Like that starts to become a really interesting topic.
And dredge costs.
Yeah, dredging costs. Yeah. So want to add anything to that?
No, I just, there are other countries using different methods besides acoustics. And I don't believe that's happening in the United States, but they're using different tools to look at density or viscosity.
I've seen dredging companies certainly use
Oh, yeah.
density measurements because they're trying to prove something.
Yes.
I haven't seen it from a hydrographic agency in the US.
Yes, thank you. Good point.
So the way that our combined engine is currently built, which gets back, this is now the last slide, I believe, is really driven by the product, which is to say that we were built to satisfy the needs of our marine charting division re-scheme process, which means we basically said, okay, where do you want what resolution? And we went through and then basically give them the resolution that they want for a particular region to satisfy the needs of the chart. So these small boxes are normally like a 4-meter product, and then as you get bigger, you get into 8-meter and 16-meter products, which isn't very satisfying because if somebody's driving around with 23 points per meter or whatever it is you're doing, Val, then it's like, what do you do with that? Like, is that all just being lost through this process? Right now it is. So what we would love to have is more of a variable resolution process that we build as part of the national bathymetry in our combined engine. And so rather than having the output be driven by the product, the output is driven by the data. So if you have high resolution data, you can get a high resolution product that then, if you need to downsample it because that's the requirement of the marine charting division, then fine. But at least you haven't essentially lost that information as it goes through the process. So we have not gone this route right now just because we need to make progress, but I do think that there's a lot of room here for improvement. So with that, in 3 minutes for all of your questions, we're having.
The camera follows me, so I'm gonna follow you.
Let me just pick right up on your last comment about the variable resolution. And I think that to come back full circle, I think that truly was at the guts of Shep's initial concept about the navigation surface was indeed preserving the data at whatever resolution it was collected at.
The highest resolution it could support.
It could support,
Yep.
exactly, and then derive the products as needed
Yep.
from that. So I think it's a great aspiration and something we should work hard to get to. I got a lot of questions, but I'll before I start doing that, except for Val, we'll have a lot of questions.
If you have a question, please speak up. It's hard to hear.
We can repeat it.
We'll repeat it too.
Okay, then let me start. You talked about the nav product, which only uses qualified data, but you've interpolated within there too. right? And so you did mention that the interpolated data would have a higher level of uncertainty. How is that, on an ENC, how is that expressed and displayed?
So
Which comes back to your question of visualizing uncertainty. I'm just curious, how are you doing now?
So the MQual, which is the, essentially your areas of different quality, essentially incorporates the information like uncertainty, and then it would be depicted there. In terms of whether it's interpolated or not, that really comes down to, could come down to also object detection, which is another aspect of like, do you have feature detection in this region? Was it complete coverage? That is another aspect of how your quality of bathymetry is graded. But if we're doing interpolation in places where there's side scan, we still have object detection. So it's really driven by the uncertainty. But if you don't have the side scan to back up the interpolation you're doing, then you are clearly in an incomplete coverage scenario and therefore, in a lower grade.
But are you doing it in a classical catsock?
Right, so
So you'll have skunk stripes with a catsock and a catsock?
it'll be like A1 with A2. So the interpolated data is like a new source that gets ingested and it's marked
Okay, so it's
interpolated.
treated as a separate source.
It's
Okay.
completely a separate source. We also do like upsampling if we need to upsample a surface that's not at the resolution of the product, and that's also treated as a separate source and marked as interpolated.
Okay, good, thank you.
In the combined engine, I think you call it, or the output of the combined engine, and the outputs of the data products are geotiffs, which of course are rasters. And I guess what I'm curious is, does the combined engine, like you've tiled the coast of the US at different resolutions based on nominal water depth and at fixed tile spacing or like fixed grid within the tile, and then the combined engine populates those as necessary, or how do you do that?
Yeah, the tiles are defined by the Marine Chart Division. That's the re-scheming of the ENCs. So they're broken up. They're designed to like cut off at the UTM zone. So we're building by UTM zone as well.
But they're not meant to have a fixed grid size within a tile, right?
Yep.
Those tiles are huge.
I guess we've got all of the band 5s, they call them, are at 4 meters. That's a good picture of it. I'm sorry, can you state your question again?
So each one of those red boxes, the data that comes out of the combined engine that goes into whatever red box produces a grid of data that is at a fixed grid spacing.
True.
True, yes. 4 meter, 8 meter, 16 meter.
Because that's the product that is requested by Marine Chart Division.
Okay.
So we're using their tiling scheme
Which is
for
a
the
function
charts.
of depth?
Essentially, the 4 meters are the smaller ones in their shore.
No, yes.
It is nominally a function of depth.
That's hilarious.
We did expand the tessellation scheme for our public products to include some higher resolution products. So for our blue topo and for our modeling, we did add some of the higher resolution boxes.
So I guess the corollary to that, I haven't looked at it in a long time, but my recollection is that at least the old specs and deliverables required like 1 meter grids at certain depth ranges. Like there were finer resolution grids that were required for the surveys for those.
Mm-hmm.
And is that still maintained, or do the surveys match?
That's still maintained. That's ideally we'll get to the point where the data is determining the resolution with variable resolution, but this is for the cartographic requirements. So this is what Marine Chart Division said they needed for contours and depth areas and sounding selection.
We gave them 1 meter data, I think, until the beginning of this project, and they were like, you know what? Like,
They
we
didn't-
don't use 1 meter data. Can you just essentially downsample it for us? So essentially, all of our data gets to the combined engine at its native resolution, and then it goes through the combined process, which then samples things essentially. Which gets into some really interesting concepts in terms of digitization, really is what it comes down to, because a lot of the traditional charting mentality is based on kind of areas and surveys as an area. And essentially what we've done is turned each of those areas into like little 4-meter cells, essentially digitized where we're working. It really gets into the same interesting concepts that you're going to do when you digitize anything, essentially sample anything.
Hang on, Tamarunada has raised his hand. I'm gonna see if he can, we can unmute him and. he can
We
ask
haven't
a
been
question.
also repeating
Repeat
people's
the questions, I'm sorry, people.
Thank you, guys. Can you hear me?
Yes.
Yes,
So that's great. Thank you for the presentation. And I'm very much interested in this because my research is about the automated cartography for updating the NOAA ENCs. So my question is regarding the slide that we're seeing right now, where we have small rectangles which represent the band 5 cells, and then the biggest one which represent the band 4 cells. So my question is, do you have the same resolution for the data that you supply the MCD with for the highest resolution data within the band 5 cells? Because I was expecting to have an edge matching between those cells if they have the same resolution. But what's happening is that sometimes I encounter a mismatch between the edges of the high resolution band, which is band 5. So do you supply with the same resolution for all the band 5 cells that we see over here, or with different resolutions?
All the band 5 should be the same resolution. All the band 4s are the same resolution. All the band 3s are the same resolution. Yeah.
So in areas where you have cells with band 5 and the rest of it is band 4, as we can see in the slide in front of us. So you have different resolutions in these cells.
So yeah, I think you're talking about like this. So like this area here where there's these band 5s that essentially exist in a band 4. So this area here would be at 8. I'm sorry, this would be at 16 meter. This is a band 3. This is 4 meter, or a band 4, which is at 8 meter, and then these ones up here. So these all kind of fall inside here. Yeah. And so you're saying these are not at the same resolution?
No, I'm saying the highest one, which is the small cells, the band 5 cells. The small cells is band 5, I believe. So the smallest cells are band 5, and then the biggest, the medium one is the band 4. So in cells, where do you have both resolutions, band 4 and band 5?
Yeah, so we deliver, like if we don't have complete coverage, like if there aren't 16 band 4s within the band 3, we're delivering the entire band 3 to support the cartographic application at the different scales.
But only to the Marine Charting Division.
Well, only to Marine Chart Division, not all of our other products. There's no overlap. We do a clipping, but for Marine Chart Division, that request was that unless it was completely full of the last band, we would deliver the entire band 3 with the partial band 4s.
Right, so that makes sense. So in band 4 cells, where you have 16 band 5 cells, you have the same resolution for all the band 5 cells.
Yes, all the band 5s will be at 4 meters.
Right, thank you for that, appreciate it.
But there's some interesting concepts there that I love to talk about. Nobody else likes to listen to, but I'll mention them anyway, which is basically how that resampling happens and how those nodes align. Because like a node-based logic versus a cell-based logic really impacts how those things work on the boundaries.
I think Paul may want to speak to you about it.
Oh, really?
He lives out all the time.
Yeah, it's like, I think I talked to you about
I was
this
gonna
2 weeks
say,
ago.
we've talked about it a few times.
Yeah, but it was, I was like, you might be the one person I know that really.
No, we all suffer from it, but
Yeah.
you guys think about it a lot more.
Yeah.
An easy kind of philosophical question. You talked about the navigation product, which is chart data based, and then the other products which are not, just NAVD 88, something like that.
And the only one that's NAVD 88 is the Blue Topo public.
Blue Topo.
Yeah.
So what's the modeling?
The modeling one is, so interestingly, modeling is not necessarily a clear term because there's a lot of modelers who want NAVD 88, but our VDATM team, at least some of our VDATM team, seems to want data on chart data because that's traditionally what they've used. So we do have
That's
an,
exactly what I was thinking. That.
yeah, so we do have an additional internal one that we're sending directly to our Marine Charting Division, which is essentially Blue Topo before it was transformed to NAVD 88. So it's the same product, yeah.
Because I think there's some subset of modeling exercises that really need to be against a true chart data.
Yeah, but what chart datum, I mean, is Hudson River datum really the datum they need?
It doesn't matter if you're predicting a tsunami inundation or you're predicting a storm surge. I think you really need to know what state of the tide is at the point.
Yeah, yep, but I think you also really need to be able to junction with the land. And to do that, you don't have mean level low water as you move inshore. So that's where I think a lot of modelers need to, they tend to work on an NAV.
As long as you're providing both.
Yeah. So so internally, we also send a modeling product that's nominally the blue topo.
And I just hope the modelers know what they need to know, what they need to have.
So do we.
Yeah, each geotiff has a tag and, it's got all the metadata attached to it. And we call out the naming scheme like blue topo in the naming convention as well as modeling. So it's hopefully clear which version they're looking at.
Okay, I just actually been turning to see the chat. And so I guess nobody's been able to hear the questions from back here. So it's something, Mike, we should think about getting our own microphone somehow in the middle.
We used to.
Yeah, we used to.
But then for the last year or so, they have microphones like there's an array up in the ceiling somehow, and it hasn't given us any problems until Will and Chris both left. Now I'm here and I have no idea.
Okay, all right. So we apologize. It's a short-term problem.
Maybe.
Just another quick one, if you don't mind. And this again is not so much in your bailiwick, but right now, how is hydro health determined? Is it what Cassie did? Is it what Christy did?
That's what Christy did.
What Christy did, okay.
Yep.
And because I've been trying to keep notes of the things you've mentioned from the context we talked about, which is what are research things that we should be thinking about that might help this process, which is a wonderful, I mean, this is great that you guys are doing. And so one of them I think is maybe thinking about the next generation of a hydro health estimate. I'm looking for you to nod or shake your head, no, that's not required.
Yeah,
Yep, I
decay,
think-
decay model.
Okay, so that's one of them. Another one I heard,
But
I'm quite intrigued.
We would like to collaborate with that though, because I think that we are actively also trying to move
We
ahead on that.
We don't want it. Of course.
Yeah.
Another one, I was quite intrigued with this Fourier method of looking at uncertainty. But it seems to me that that's something that really has to be evaluated in a number of different environments. Because I could really see a scary situation where people just say, oh, this is the number, we apply it everywhere, and we get in big trouble. So I could see that being a nice little project of really applying this in lots of different environments.
Oh yeah, you should be building wavelets and essentially modifying it as you drive along the line for how far out it goes. Like there's so many cool things you could do with that.
Yeah,
Like,
no, I don't argue that, but I think until we know, we need to make sure that we're not just applying one answer to everywhere. You know,
you mean like what we're currently doing?
yeah, exactly. The fluff bottom seems to be an interesting issue that we've never paid much attention to here and may wanna, and of course, well, variable resolution products, as you and Brian have looked at already, and I think we're always thinking about, but the other big one sounds to be still, for all the years, and it's been in our proposal every year, and Colin and Christos are certainly looking at, and I hope you're keeping up with what they're doing, the idea of how we really visualize uncertainty becomes a critical issue at the end of the day in a product, from, as you said, a visualization perspective. So I do hope you're keeping up with what Colin and Christos have been doing. They've been doing a lot of kind of prototyping there.
Well, I think it's important to also recognize like who's going to care about it, because knowing your audience and who's going to care about it naturally, of course, is the insurance companies, which is why I think Brian kind of came at it from that risk model perspective, which I think is good. It's just I don't know that really anybody picked that up. Yeah.
In the chat, Christy has a question. She says, I really like Cassie's approach, but how can we scale it up to a national scale? How far can we extrapolate out decay?
For the hydro health, yes. I don't know if that's a rhetorical question, but
I don't know either.
That was a question for Val, I think, right?
I think Christy is put a lot of effort into hydro health, and I think she's very interested in.
She
how we
says
update-
rhetorical.
Rhetorical. Great.
Sorry, I didn't pick up on that. I had no idea.
But I think
I'll just keep my mouth.
going back to the uncertainty, do you mind going back to the Gulf of Maine slide real quick? I think, we're talking about users learning about uncertainty, and I think it was interesting when the Gulf of Maine folks doing seascapes. Oh, we put closed captions on. That's cool. They go up. It's right after Blue Topo, the pipeline. Yeah, to your left, slide 22. 22. Yeah, so it was funny because a lot of Maine is not surveyed to modern standards. So there's a lot of really sparse data. And so their interpretation of bad quality was to just put a hash on it to be like, this is bad. We know our geoforms are going to be bad because the bathymetry is old and sparse and it's kind of gross. And so I think that was interesting to get that kind of community to really think about it in terms of my product is not going to be great if I don't have the data to support it.
But I think in this community, that's an easier problem than the navigation community.
Yes.
Where you really have to, you got to cross that area.
Yes, you got to go through.
So I think we really need to look for a way that'll really give the mariner, without having to go look up a CATSOC table, some really instant and intuitive way to understand how good the data they're traveling over are. Will be.
Yes, and modelers too.
Yeah. And modelers. Yeah,
that's a
absolutely.
huge input to their model. Yeah. Thank you. Any other online questions?
But let me thank you. I mean, this was really important. It's really great stuff, I think. And I think it was really important. And there was a small group here, but there were 40 people out in the ether land there. And the more you get this message across, the better. So I really want to thank you guys for Friday afternoon in the summer coming in to do this.
Because they're definitely tackling problems that are really hard.
Yeah.
Well, and a lot of them have kind of halfway solutions because we need to make progress. So
the other side of it, we are here to help. That's our job.
Yeah.
And any way we can, we should be, and we just need to keep talking.
Yeah. Agreed. Great. Well, thank you so much.
Oh, could I sneak in just a quick teeny question before everyone goes away, or did I miss my chance?
Please.
Yeah.
Oh, so are there any plans to serve the specifically the images in a way other than through AWS? Because I've been working with, or a website I'm working on was going to be displaying the bathymetry images, and the Precision Nav Gateway website has them being served through WMS, which I've been using, but they only have it for New York. So do you know if there are any plans to make the other areas also available that way?
Yeah, so our Now Coast team under the Coast Survey Development Lab is planning on serving up Blue Topo, not only for visualization of the bathymetry uncertainty contributor, but also through services. So you could open it up, like a WCS and use any GIS you'd like. So they are, I think, a few months out for rolling that out. We do have internal services, so that's for the other pipelines, but the other one is the Precision Rig Navigation Gateway. We are testing a lot of the S102 products, and so those should be going not only to the bucket, but also to a service where you can see the data.
Do the geotiff tiles, for each of those red boxes, live someplace? Are those pre-compiled and just updated periodically?
The actual tessellation, yeah, that's published through the Marine Chart Division service. They have the rescheme service that has the different
Is that open
cells.
to the public?
Yeah, and we also posted that on the Blue Topo AWS page. So there's a geo package with the tile scheme, and then Glenn wrote some code on if you want to download it. If you want to pick your area of interest, you can. So you don't have to.
Is there a link for all that at NCEI? Because to get access to all that, I'm just thinking because the public in general, when they think about where they're going to go, or the informed public, I should say, where they would go for bathymetric data, we tend to go to NCEI. If you type in NOAA bathymetry, it's going to take you to the NCEI database, and which does have links to the NOAA hydrographic data and things like that. But it might be very nice if there was a link from that to this, so people don't have to know that there's a separate Bathysource project going on.
Yeah, so interestingly, NCI has their own compilation that they publish. So I think we did have a meeting with them maybe 2 years ago about like what we were doing and just kind of came away. They were like, okay, you're doing
This
what
is
you're
interesting
doing.
because this could also lead to great confusion.
Yep.
And I think having the service up will help, because I think having the service published and that like as we post new data that come in, the service is updated. I think that's when more people will suck it in for like, you know, the Northeast regional, like they want their service and like marine cadastre. And so I think having it more accessible, we'll get more distribution from it.
I have another question. What are your feelings about people using the raw geotiff data for navigation without the cartographic generalization applied? Like just using that directly?
The blue topo data?
Uh,
It's on an NVD88, and it was put there to satisfy modelers, but also to make it clear, it is not for navigation. Because it includes unqualified source.
Yeah.
It's definitely not for navigation, and there's a disclaimer in the file, like, don't sue us.
When some Garmin or somebody kind of grabs it, maybe Garmin's a little too big to do it, but somebody grabs it and starts providing it over the web with a little sign said not for navigation. There may be a lot of recreational boaters who love to travel along this 3D view.
Well, I think that ideally what they'll be doing is pulling it directly from the precision marine navigation.
Yeah.
Because that's where the same data will go, and we'll have everything that is qualified and on the right datum for navigation, and then it can be used by anybody for that purpose.
is that always gonna be around like high density, big ship ports?
Yeah.
Precision navigation?
That's a good conversation.
I go one no and a look.
That's a good conversation.
So I think the MBS team believes that everywhere we are producing this product, we should be producing precision marine navigation, because that should just be how people think about imagery. And if it essentially just serves different user groups, people that want to be able to twiddle the knobs, then like they get everything. If people that want the cartographic traditional thing, then like they should be able to have that too.
And there are businesses now where you can, you know, pull in high resolution bathymetry on your phone and navigate.
Yeah.
Not
Yeah, not for navigation.
for navigation,
Yeah, that was my point.
but yeah. Good question.
I think about it because we wrote a paper about how to take a cartographic chart and turn it into a raster product that we could then navigate on for a robot boat. But it'd be nice in many ways. It may be also dangerous in some ways, actually, as I think about it more, to start with the raster product from which the cartographic product was generalized. That makes sense.
Right. And that's where we have the uncertainty and the different, you know, this is generalized, this is interpolated, you know, that information carries through to that product, so that might help inform some of that navigation.
Just type in NOAA bathymetry. Just type.
So, well, I just wanted to, I think that there was a question about, getting to the, so you wanted the tessellation scheme, I think, which is here. So this is what we're putting up for Blue Topo. This is not the like full like MCD sweatsuit. Like there is a slight departure here because we've started producing more high resolution tiles because it's killing us to do some of what we do. So we've actually started creating some additional tiles that are included here if you want to know like what we have. Like you can pull it down from there. Why am I not able to do that? Oop. Just slow. But in terms of having some of those kinds of products, Val, you might find some of what you need maybe in some of these folders where you could pull down some of that stuff to maybe play with those kinds of things. These are all bags, so they won't have that additional contributor layer that you would find interesting, I think, as well, but you have the uncertainty layer and otherwise.
Can you share the screen again?
Oh.
Can
Stop
I-
sharing.
That's a good question. Can I share the screen?
Yeah.
Probably.
Yeah.
Yeah, sorry for
So
people.
those bags in this folder that he's sharing is where the S102 test and evaluation products are being created from.
And now the question is, Are those bags identical to the bags being served at CEI?
No, so these bags are essentially what go to precision marine navigation. So these are being created because there are a significant number of pilots out there using software that can't take the newer version of S102. And so essentially what comes out of precision navigation is just not compatible yet. But they can read a bag because the initial version of S102 was a bag. So these will work in some of those pieces of software. So this allows the pilots to start to experiment with it, which is exactly what Katrina was showing in like the LA Long Beach area. We've been giving them these files for years now.
It's the combined data, so it has the Army Corps data and all the recent.
But it doesn't have the contributor layer, so they can't tell the difference, like this is the date of the survey and who took it and what's the quality, like all those things are lost. But the updated bag, which may not work in this context, but ideally S102 will have that. So I guess I don't, so they did, which is what Katrina was referencing, just for, I forget who asked the question, but on GitHub, if you go to the, I think it's OCS Hydrography organization, there's a Blue Topo repository, which you basically, if you hand it a geometry file of some sort, it will then go here and download all of the tiles that intersect that bathymetry. So it's an easier way to access this, than we don't have the services yet. So the services are coming, that will be the best way to do it. But until then, this was specifically to help like some of the folks with the Texas Water Initiative or.
Yeah, we put the link on the Blue Topo page, or the newest version, I think is when it goes out.
Yeah.
To get out. I don't know why the camera's just following me, I'm sorry. If you wanted to get in on this, it's gonna go this way.
It knows.
It's very strange.
It knows who knows. Okay, thank you again.
Yeah, thank you.
Thank you all, I appreciate you coming.
All right.